So thank you for inviting me to present here, and it was really nice working together on this paper. And I think as was already mentioned by Pablo, this is something new to add soil carbon into these kind of LCA analysis of carbon footprints. So there was also a challenge how to do this and at what scale. So I want first to show a little bit how we did this in the paper, but then also tell a bit more in general about soil carbon sequestration, as there is a lot of attention on carbon farming, etc. So to broaden it a bit further beyond the paper. I most times start with this slide first to introduce the carbon cycle, because it's good to know that we have two kinds of cycles, the short and the long-term carbon cycle. As for climate change mitigation and in the accounting and the footprints, we only have it about the long-term carbon cycle. So, and then it's really about the net change in soils, what accounts. So when a farmer says, I sequester a lot of carbon in my grass, indeed he does, but most of it is released during the same year. So what is actually counting and what you store additional in your soil. And as there is a lot of carbon in these soils, and we know that the flow to the soil is really large, more than 10 times larger than the fossil emissions. If we can then, sequester a little bit of this flow in the soil, then potentially we could sequester a lot of carbon. But that goes not beyond changing practices. And one of the things is, how to get it then to quantify it. We can just go into the field and measure it, but we also know that that's not an easy thing, as we have already a large stock. We talk about small changes compared to what is added to the soil compared to what is already there, and we know there is measurements. The accuracy of the measurements is not that high, so to quantify this change is quite difficult. And we would need many soil samples and over longer times to get really significant changes. Of course, there's a lot of things happening now with new methods. We're using remote sensing, new sensors in the fields, improved sampling designs, which will all improve this. But so far, we are not yet at the stage. I think we can do it only by sampling. And therefore, we need models to quantify this, and especially if we look into the future. And that's also what we used for this footprint. So what we used is the ROT-C model. It's the Rothamsted carbon model. It's a process-based model to simulate the dynamics of organic carbon in the soil. This has been developed already quite some time ago in the UK at the Rothamsted Institute, where they have very nice long-term trials for more than 100 years already there, like you see in the photo, with plots with different treatments, which is, ideal to calibrate such a model. And it's, also a model used a lot around in science and in many projects. And one of the benefits is that we only a little set of input data is required. So it's also makes it achievable to do this. So what we did is use this model for a kind of imaginary average Dutch farm, then for which we then simulated this whole carbon balance. So how did we set up the simulation? First, we had the land use, where we had three main classes with permanent grassland, temporary grassland, and fodder maize. And we made a distinction between two soil types, sandy soils and clay soils. And this is representative for the Dutch conditions. So we have a bit more on sandy soils, and about 62% and 38% of the land for dairy farms is on clay soils. We set a fixed carbon content for these soils, and then we simulated these land uses. And we see, this is a trend that was shown already by Jeroen as well. Then for the inputs, the main inputs are organic matter from crop residues and organic inputs from manure, compost. So these, in the graph, you see the development over time. For crop residues remains more or less stable. The main part is really carbon input from grassland, the roots, and which are decaying. And we see a decline, as shown before, on grazing manure because there's less grazing, but an slight increase in the other types of manures. But overall, there's a decrease of carbon inputs, mainly because we have lower manure inputs as a total. And the last years, you see a slight, well, there's a slight increase in cover crops, but it's still a minor input compared to the total. So then we get the results of these simulations. It's the net carbon sequestration on these farms. So in the left graph, we see the carbon sequestration per hectare, which we had a positive balance in the first years. But we see in the more recent years it's around 0. So and that's due to the lower inputs, mainly of the manure. And then if we convert this to the soil carbon stock, well, we see that overall the average carbon stock on the dairy farms is still increasing, but at a lower rate. And if we compare over the whole period, we are talking about a 4% average increase in soil carbon on an average dairy farm. So it's not a huge increase over time, which we are measuring. But of course, this is an average value, and for individual farms, the picture can be quite different. So this is the picture shown before. So the green part is the contribution to the total footprint, which is at the end quite small. On average, carbon sequestration is about 20 grams CO2 per kilogram of fat and protein corrected milk. But we see also a high variability, and which is due to the annual variability, mainly due to climate. So the model is quite sensitive to the weather data. So there's also a question which kind of data to use. Do we really use annual data? Do we use average climate? So this is about what we did for the footprint study. Well, this was done work mainly in 2021. Over the last year, we did also a kind of similar work for the national greenhouse gas inventory, which is the LULUCF, as already mentioned. It's about the land use sector and all emissions related to that. We did a similar exercise for the Netherlands to include now the dynamics of soil carbon for cropland and grassland soils in the Netherlands, where again we used the ROTC model, but now at a spatially explicit scale for postal code regions, about 33,400 units in the Netherlands. We have a detailed soil map with the soil organic carbon content used, created by digital soil mapping based on an inventory of about 1,100 points where soil organic carbon was measured. And we have input data from different sources, statistics, well-detailed crop areas, the climate data, etc. So based on this, we did a similar exercise. And here we see, this is overall for cropland, we see an increase in the carbon inputs, which is mainly due to an increase in the use of cover crops, especially over the last years. And in grassland, we see a slight decline. But this we have to say this is from the period 2005 until now, whereas we in the paper we started at 1990. What is the result for this? Also here, a cropland, we see a negative carbon balance, and for grassland positive. For grassland more or less stable, whereas for cropland we see an increase, especially in the last years because of mainly due to more cover crops, but it can also be some cropping patterns changes. Also here we had, we saw quite some annual changes if we used annual climate data. So we decided for now to use 5-year average data. So this will be reported in the upcoming national inventory report, where we have now a tier 3 approach for these soil organic carbon. Well, this is not only at the national scale, also at the last year in the ANCA tool, the kringloopwijzer in Dutch, soil carbon was introduced. Was also a question from the sector. Campina also would like to have it for farmers. So maybe for the people who don't know, the ANCA tool. It's it's a tool that almost all Dutch dairy farmers have to use, which calculates the nutrient flows on the farm, but it also calculates the carbon footprint. But so far, soil carbon was not in there. So that's now included. It's really still indicative results and not included in the final footprint figures. But this is really to make farmers aware of the soil carbon. It's not yet all farm-specific data, like soil carbon is still based on regional data. But the idea is to get really the farm-specific data for the soil carbon measurements. And on top, also emissions from peat soils were included, and that's now also shown in the results. Well, I heard from an advisor that he looked at his farms and they, on average, had a 5% lower carbon footprint because of the soil carbon sequestration. But I haven't seen any full results for maybe Jeroen already had a look, but no. But at least it's nice that it's in there and it gives awareness to farmers about soil carbon as well. Then on my last slides, I want to discuss a bit more on carbon farming. We see now a lot of attention for carbon farming. So carbon farming is really managing carbon pools and flows and greenhouse gases at the farm level to mitigate climate change and to receive a payment for the action they take to sequester carbon. So the EU wants to stimulate carbon farming and provide private revenues for farmers, but it also requires public support. And one of the final goals is to reach climate neutrality at EU level, which is the graph is showing. We really need to increase the carbon removals. We cannot reduce all emissions to zero, so we need carbon removals to come to climate neutrality. So that's why the EU is also setting up this the scheme for certification scheme for carbon removals. It has been published, the regulation for the framework in December last year. But there's still a lot of questions, and there's an expert group who will look at how to get the details for the certification right. And that's about quantification. How do you quantify the removals? Are you sure it's additional to what is already being done? How about long-term storage of carbon? And how do we ensure that it stays in the soil? And is it also sustainable? And is it linked to issues like biodiversity? So these are discussions that will be happening over the coming years, and I think it's very important for the kind of projects that will be starting around carbon sequestration. Because, for example, in the Netherlands, we already have a first methodology for permanent grassland, where there is already projects. That's the so-called the Stichting Nationale Koolstofmarkt, which organizes this. And we developed a methodology for them where farmers can participate in the projects, and they have to ensure that they really have permanent grasslands. So no plowing, at least for 10 years, but ideally much longer, of course. A group of farmers can start a joint project, and they should, at least 50% of the farm area should then participate in as permanent pasture. With the model, we calculate what is the potential sequestration over this period, and the farmer receives then every year 5% of the payment for the certificates, and at the end he can receive an additional 50% if it's verified. And in that way we do a measurement. You do a measurement at the start, and after 10 years, and if at project level you achieve indeed the calculated sequestration, the 50% can be paid. So this is already starting. There's projects going on. I think Friesland Campina also is looking at it, starting maybe projects on this. And another methodology for arable land will soon be published as well, so that can also then be used on a similar methodology for arable farms. Well, what are the kind of practices for dairy farms? It's, of course, maintaining permanent grasslands and increasing the area. For fodder mate, you can think about doing strip tillage in the grass, having good cover crops after maize, so application of solid and manure in compost will help. And yeah, species-rich grassland and deep-rooting grass species, we expect them to contribute, but we don't have really hard data yet, as there is no good long-term trials on these. But for the future, and there especially, there is a link with biodiversity as well. So my final slide, yeah, how to make this happen. Well, first of all, we need to create awareness and insight. And I think that step we can now have with tools being there to calculate it, with the Anka tool having soil carbon in there. We have to have harmonized rules for carbon certificates. Well, that's where work is going on now. Yeah, farmers should receive a fair price if they start these practices and probably combine it with other ecosystem services. And an important thing is how to monitor it and get that in a cost-effective way. And I think this is still a part to be developed further. Thank you.
Thank you, Jan Peter. You can sit in the panel on panel chairs. Jeroen as well and Pablo. We're going to go for some questions. We're really running early, which is not a bad thing because we can have more questions and we can have more break time. But we had only 15 minutes, so we could have also longer. I think we will start